In philosophy, there are what we call the traditional proofs. These are arguments for God based upon the universe or morality or a variety of types of issues. It seems to me as a philosopher these days, some scientists seem to imply that there is no need for a causal agent to bring the universe into existence, that somehow things like quantum mechanics and other ideas make God superfluous. We've brought Erica Carlson to come in. She is a PhD physicist, a professor at Purdue University. Erica, am I right that there are scientists who seem to be implying that quantum mechanics doesn't have room for a causal agent? Help me sort that out.
Oh, okay. So I have heard, not necessarily scientists, but I have heard philosophers make this argument about causality. I mean, the truth is that we scientists are very honed in on our own discipline, and although, as you as a philosopher know, there's a lot of philosophy and philosophy of science that empowers how we do things.
Right.
We're not always trained to think about those logical underpinnings. But I have heard philosophers of science, particularly Alex Rosenberg, talk about this idea of perhaps there are uncaused events in nature, and if there are uncaused events, then maybe we don't need to think about the universe having had a cause at all. Maybe there's no need. And so I had the privilege of interacting with Alex Rosenberg when he visited Purdue a couple years ago. He was there to have a debate with William Lane Craig, and he's certainly a very deep thinker and has some extremely interesting ideas. But I was struck by something that came up in the debate. He did make this argument, and he was basing it on radioactive decays. He was using that as an example, and the argument was something like this: because we cannot predict when a radioactive element will decay, therefore there are uncaused events in quantum mechanics, therefore we're not logically compelled to look for a cause for the universe. Now, as a scientist hearing that, we think about cause very perhaps differently, or perhaps if I got deep enough into the philosophy of science, I would learn there are 7 ways to define cause. You can talk to me about that later. But the way a physicist would describe this sort of thing is we would say not that these radioactive events are uncaused, or even that the timing of them is uncaused. We would say, look, we can write down all the equations for this stuff. We know exactly why. By the way, I should perhaps define radioactive decay. So you know how atoms are made of, they have a nucleus in the middle and they have electrons that run around. Inside the nucleus are neutrons and protons. And every once in a while, a proton will spontaneously decay into a neutron. It'll eject a particle as it does that. Or a neutron may do the same thing, eject a particle and convert into a proton. There are well-defined timescales on how often this happens. When that happens, it's called a radioactive decay, and that atom then changes its character. From one atom in the periodic chart, it'll shift over and become a different atom. That's a radioactive decay. So they happen on well-defined timescales. They happen for well-defined reasons. So from the scientist's point of view, we would say we understand all of the causality there. We know exactly why radioactive decays happen. And we know what timescales they happen on. Now, when it comes to a single radioactive decay, it's true that we cannot predict when it can happen, but when it happens, we know exactly why it happened. So I guess I would take issue with the language there of causality, and I would say we do understand the cause of those things. So I don't think it's actually fair to argue that quantum mechanics has uncaused events. We would say they absolutely have a cause and that we know what it is.
Now, speaking of causality, I remember the first time I read Gottfried Leibniz, great mathematician, great philosopher. He's known for what I think is kind of the ultimate metaphysical question: why is there something rather than nothing? As a physicist who is a Christian, how does that reasoning, that basic cosmological reasoning, strike you?
Well, I'm a fan of that line of argument. I look at things and I ask the same question: how is it possible that this stuff is here? One of the ways that I see that coming up in my own work as a physicist is that, as we said before, I'm a theorist. I write down math. I can write down a lot of math. It may or may not have anything to do with the actual physical universe. So just because I can write down equations that are self-consistent and logical doesn't compel them to have a physical insubstantiation. So, so the fact that there is something rather than nothing really does take someone to make that thing and make it happen.
Right.
So another place that I've seen this issue of nothingness come into these kinds of questions is the idea that perhaps, is the following idea that the vacuum in quantum mechanics, it's called. Vacuum's a little hard to describe in lay terms, but think of that as the closest to nothing we can get in quantum mechanics. What it looks like, though, is empty space, but it's kind of roiling and bubbling with particle-antiparticle pairs, all right? And so things can pop into existence and pop back out of existence. Now, to do that, what's going on is if a particle-antiparticle pair, for example, an electron, every particle has an antiparticle pair. That's what antimatter is. If you've, read or watched any science fiction, we love to talk about antimatter. Actually, there are experiments Purdue is involved in that are testing antimatter hydrogen. So it's real stuff. It's not just science fiction. But when these particle-antiparticle pairs pop into existence, you should think, energy violation, right? Because there's mass associated with them. Einstein taught us that mass is another form of energy. So these would, on the face of it, appear to violate energy conservation. Now, there's another... There's an energy-time uncertainty principle in quantum mechanics. We talked before about the position-momentum uncertainty relation. There's another one, which is energy versus time. And it goes something like this. The larger the energy violation, the faster the bill becomes due. Okay? So it's almost like these particle-antiparticle fluctuations are borrowing on credit, and then, the creditor comes knocking quicker if it was a larger bill. So these things can fluctuate in and out of existence. Particles can fluctuate in and out of existence. But the more massive they are, the quicker they have to go back into nothing. And what scientists mean by nothing in that context is a very specific type of nothing. It's, there's a pre-existing space, there is a pre-existing time, there are laws of physics imprinted on that space and time. All of that is quite beyond what philosophers typically mean by a proper nothing, right? I don't actually know what language you use for it, but it's it's different, right? It's this question of why is there something rather than nothing that Leibniz asked really was about nothing, not even the space, not even the time, not even the laws of physics that allow these quantum fluctuations to happen in the first place.